Well, welcome YouTube. Another installment of Drive It Home. Appreciate you coming out and listening. Seems like we get a little bit of traction on the YouTube site. So wanted to ask if you get a chance to subscribe. Just kind of trying to boost a little bit of my exposure here. But to those of you that are listening, I appreciate it. Hopefully the things we're talking about here are helpful. I was able to get in a video tonight. It's been a minute here, and part of it's been dark when I've been leaving, so hard to video in the dark. So here we got some daylight going, and was going to use a catchphrase that I use in class that's come up quite a bit. So it's been popping up in our foundations class, our structural class, our site layout class, and that is water is bad. So anybody who's been involved in construction understands what I'm talking about and the importance about control of water. And just to kind of give some background to this and some learning knowledge into why this is important and what building systems we concern ourselves with when we talk about water. Initially, water is a site civil concern. So controlling stormwater on your site is a big component of trying to keep your building dry. So getting stormwater away from not only your building, but all structural improvements or surface improvements that you put in. And you see it every day in paved systems. There's some sort of stormwater control, whether you're running stormwater off into a ditch, running it off into a catch basin, whether it's going into a pond or a cistern, or any type of detention or retention facility. We're trying to get that stormwater controlled, and any of that water that can get back towards our structures it can be detrimental. So it depends on the volume and then what happens with that moisture when it's there. We're in the beginning of February here. We get some real balmy temperatures today, so kind of running teens and 20s mostly right now in Wisconsin, and that means water is frozen. Water gets in and around your pavement or some of your structures, so your storm structures, your potable water, so your hydrant underneath your water lines, sanitary lines. Anytime we get water that is now around those structures, it will freeze and it will expand. And that's where the water is bad this time of year. So what happens is if you live in a northern climate where it's cold and temperatures start going down, you start feeling it in your driving. So pavement is definitely one of those very noticeable impacts from frost, and frost essentially does its damage when it's freezing the moisture in the soil or subgrade or base material that's underneath the pavement. We want to keep that dry, get the moisture away from it, so it's not doing any damage there. Drainage away from the building, the next step would be keeping it from our footings and foundations of whatever it is, whether it's a sign, a retaining wall, or the building itself. And that is huge. We don't want any frost underneath our footings. So in northern climates, we're getting down below the frost line with our footings. That's a code requirement. And then drainage around the footings to allow any moisture that would come in from the surface to get away, out and away through drain tile and other drainage systems around. So that's really an integral part of the footings and foundations to make sure that moisture stays away. Now let's just remove the freezing element from it and just say, well, what happens if I'm in a climate where there is no frost? Well, moisture is still going to be an issue. A lot of it is going to depend with your footings and foundations, what type of soils you have on your site. So if I have a soil that we have cohesive soils and cohesionless soils. So cohesionless ones are ones that don't bond real well. Sand is one of those, and water will drain through sand relatively easily. It will drain through stone and aggregate relatively easily. What it won't go through is some of our cohesive soils like clay, and clay will trap that water. Clay loves water. It will soak it up and it will expand. And some clays, we call them fat clays, will expand at a pretty rapid rate. So now you've got a hydraulic pressure that's around your building. It's going to put pressure underneath your footings. It could put pressure on your foundation walls and start doing damage that way. So we want those types of soils to be kept kind of away from our building. And if they are going to be underneath our footings, we want to keep that moisture kind of tempered or controlled so that we don't have any expansive issues where it could potentially raise the footings or raise the slab underneath your building. So, it's not just frost, it's hydraulic pressure. Groundwater is a whole different issue, and if you're building in an area where you've got groundwater that could be up in and around your structures, mechanical means of controlling that stormwater. You might have a sump pump in your basement that pumps stormwater away, and that's one way of doing it. It does get difficult when we rely on mechanical means to keep that water away. Water is an extremely powerful force, so trying to control that with the idea that a mechanical system is prone to failure, and we could have subsequent larger issues should that system not be operating anymore. So that's kind of around our footings and foundations. We control it on the upper layers of our building. We're obviously trying to keep our building watertight. But stormwater, as we think about water and water shed away from the building, our primary collector of stormwater would be the roof system, and trying to control that water, the stormwater that lands on our roof, and then how do we get that away from the building? Commercial structures typically will have, if you have a low slope roof system, have internal roof drains that are going to drain down into the stormwater system and get it away. Simpler systems, kind of gutter and downspout type applications, maybe just distributing stormwater out onto a splash block and then out onto a porous surface, a lawn or something like that. And if we're not allowing it to get far enough away from the structure, it's going to come right back into the footings and foundations. And movement of that building also can basically create bigger issues. So if the building begins to sink because of moisture issues around the building, now it becomes kind of a bowl, and it's going to collect more stormwater, and more stormwater creates bigger issues, and it just compounds. But the bottom line is with this is stormwater control and keeping all of your installations as dry as possible is a critical factor for any successful development or construction project. And I don't know that it gets enough credit for all the systems that have to come together to make that type of improvement work. But again, it's a natural element. We have no idea how much and what volume that it's coming, and we need to prepare for that. Stormwater calculations are done for pretty much any commercial site to know how it's going to control all of the stormwater that hits that site. And in some areas, you're actually going to have to contain and deal with, so either retain or detain stormwater on your property. And I've been using that retain detain thing. So maybe for a listener that's not quite sure, you see a stormwater pond and there's a retention pond, so re with an R, or detention pond, D with a D. The easiest way to remember that is a detention pond, D for dry. Those ponds are designed to drain out, so you generally have soil that's going to drain out underneath. A retention pond is one of those that always has water in it, and it's designed to be a retention facility. Its secondary function is to collect any sedimentation that is in that water as it runs off of your different improvements, and then it becomes a collection basin for that, and clean stormwater will run off the top of that into another installation. So it's not really designed for groundwater recharge like a detention pond is, but it's more of a cleansing factor to help clean some of that storm water as we return it back into the environment. So I'm hoping this was helpful, maybe clarifying a few things, making you remember or driving home the fact that water's bad. Obviously, water's a natural part of our life and we need it. But when it comes to our improvements, we want to control it and keep it from being destructive around any of our installations. So again, thank you for listening, driving home the fact that water is bad, and we'll see you next trip.